Okay, so let's start from talking about Nidec. Nidec is a quite huge corporation. It's a Japanese one, founded by Mr. Nagamori, that you can see in the picture. He is the man that created this big group, starting for making small electrical motors for computer disk drives, and then expanded along those years, becoming a really huge corporation. And recently, I mean in 2019, Nidec acquired Embraco. Embraco starts to be part of Nidec Global Appliance, that is a division of Nidec that is working for home and commercial appliance industries as a supplier of components. So the headquarters are in Joinville in Brazil, and in Italy in Pordenone, has 14 manufacturing plants and other offices, 9 R&D centers, and is producing almost 65 millions of motors for household application or for compressors. Global Appliance has basically 3 brands under this name. First group is for home appliance. It means household compressor for household refrigeration, and motors and pumps for dishwasher and dryers. We have the brand recently entering our group, the motors for ventilation, air conditioning, basically the American US Motors and Rescue. And the division I'm part of is Embraco Nidec Commercial Appliances, that is producing compressors and condensing units for commercial refrigeration. So our fields are basically related to the home appliances for fridges and freezers, and mainly in commercial applications that are many. So there are bottle coolers, chest freezer, reach-ins, other type of commercial applications that are part of our customer products. And then obviously we are serving also the aftermarket with the parts and distribution centers. So very shortly about the compressors we produce for home and commercial appliance are mainly in the range up to 2 horsepower. So we have different sizes of compressor, both in fixed and variable speed, and we have as well the scroll compressor up to 13 horsepower. Obviously, with those compressors, we are supplying condensing units or even full cooling systems for commercial refrigeration. So Embraco is first of all promoting natural refrigerants use, promoting high efficiency. It's innovative, and obviously are delivering reliable product for all our customers. Okay, so this was the introduction of Nidec Embraco as a component supplier for refrigeration. So here is more details about type of market we are serving, mainly merchandisers that are bottle coolers, ice cream freezers. Then you have food service and food retail, and the specialty application like medical, for example, low, ultra low freezers and such kind of stuff. Let's start talking about refrigerants. You know why we are talking about low GWP refrigerants? Because we are facing the climate issue. So in 2016, I believe, yes, that was signed the Kigali Amendment that is now valid worldwide, even if not all the countries signed it. We have, I think, more than 100 countries now ratified or agreed to adhere to this Kigali Amendment that is considering reduction of production and use of high GWP refrigerants in refrigeration and air conditioning. So there are different regions of world that has different, let me say, plan for reducing this total CO2 emission because of use of high GWP products. And the red line you see is so-called developed countries. That is the let me say basic line that should be followed by all the countries. In Europe in particular, we have a little bit tougher steps. So as you can see in 2021, we will have another reduction of quantities of CO2 equivalent we can emit in Europe. So as you know, now F-gas regulation that is stating all those elements is under revision, even if there's not expected any acceleration for the moment, at least in what I can see in the horizon. So Europe will keep the steps that are in this plan. Now, to go down with GWP, we have to choose alternatives that are low GWP. And except CO2, water and air, no, I didn't mention here. All the other refrigerants are in some way flammable. So, or they are classified in different classes, depends on their properties as A2, A2L, or A3 safety class refrigerants. To be applied in the real world, the flammable refrigerant needs to have an update or has to be considered by the safety standards when producing any kind of equipment. In the world of standardization, there are two main types of standard. One, a so-called general standard, they are covering broader range of systems or type of applications. And then you have the product standard that are dedicated to specific type of product, like for example, household fridges or commercial compressors or air conditioning. So those are so-called vertical standard or product standards. Those product standards are standards. So the applicability of those standards, it depends on the national or regional regulation or laws. So the standard itself are nothing. They have to be mandated by the local authorities to become something that you have to comply to assure the safety. In many other countries, standards are applied just in voluntary base. There is one important rule in the standardization, that if there is a product standard available, it's prevail over the general standard. So, for example, if you have the plug-in application that is inside the scope of the product standard, you should use the product standard instead of general standard. Now, this is let me say, general picture of how the standardization is organized in the world. We start with so-called international standard things that are under ISO organization, on IEC organization. They are global, no profit. I think it's under your World Trade Organization as a system. They are developing the general standard, the ISO, in this case is 5149, that is general standard for refrigeration. And then you have more committees inside the IEC, International Electrotechnical Commission, that is taking care on different standards. In particular, 61C is taking care of two important standards for refrigeration, DES 24 and WES 89. I have the honor to be a chairman of this committee, and as I will explain later, we introduced several important changes, mainly in DES 89 standard that is covering the commercial refrigeration. Now, the important standard is DES 40 that is presently under CDV stage with 61D committee under IEC. IEC is creating product standard as a, let me say, base for introduction of those standards in different states or regions. In some places are becoming immediately valid. In regions or countries like Europe, US, Japan, or Australia, they have to become local, country or regional legislation to be used by local authorities and apply them in the market. Okay. So in Europe we have EN 378 as a general standard. We have EN version of 89, as well as the other regions as indicated in this chart. I will be talking about status of implementation of the commercial refrigeration standard in the slides after this one. Then what happens last year? A very important step. IEC 61C subcommittee that I'm leading approved the edition 3 of DES 89 standard. It was published in June 2019. What this new standard, which products are covering? Covering most of the plug-in applications. What is excluded from the scope of the standard are the dispensing machines, air, and also cold rooms are excluded from the standard. So, for example, in case of dispensing machine, this is the 75 standard. For walk-in rooms or cold rooms, the general standard has to be used because it's not part of the product standard. This new edition of DES 89 introduced the larger charge limit for flammable refrigerants. And the max charge limit for each circuit becomes 13 times LFL, but not more than 1.2 kilo. So what does it mean? That in case of propane, that is 13 times LFL, is almost 500 grams. 500 grams is the limit. For A2L, and here is the example of R32, even if 13 times LFL is almost 4 kilo, the limit that was approved by IC was 1.2. The reason of this 1.2 is related of the cooling capacity that is theoretically possible with the certain quantity. So committee at that moment decided that it's not necessary to go to the larger values and therefore increase the risk if the 1.2 kilo is enough to provide the same cooling capacity that 13 times LFL of A3 class refrigerant. Next item is, as you know, 150 was the historical limit for flammable refrigerants in the past in most of the standards. Requirements for the systems are not changing. So this new edition is keeping all the requirements that was used before for under 150 grams. There is a new type of machinery that was introduced in this edition 3. There are commercial ice makers that was before under DES 24 standard. Now they are entering in the DES 89 scope. Therefore, this charge increase will apply also to the commercial ice makers. For remote systems, the committee are still not considering use of higher charge level for remote system because basically it's what is required, and this was written here. This system has to be hermetically sealed. As you know, those things can change in the next months or years because more and more requests from the market to use flammable refrigerants in remote system is growing. And in fact, there is EN 378 or 5149 that is already considering this possibility. Other requirements for the systems above 150 grams and below 500 grams of propane or 13 times LFL is that all the refrigerant containing parts has to be protected and not accessible. The construction of the appliance has to be such to not create excessive vibration or resonances, and the system has to be marked with the minimum floor area which this appliance can be installed with the symbol you can see there. So the symbol has to be applied in the visible manner when the machine is installed on the field. Then obviously the flammable refrigerants are present several risks, and main risk when the charge is going up is to create the flammable mixture, not so much internally to the machine, but outside, because you can have close to the refrigerator or appliance, you can have potentially the ignition sources. So the main way to apply higher charge is to provide airflow that will minimize risk of creating such a flammable cloud around the appliance. And this is verified in the standard by the Annex CC test. That you can see some indication of the sensor position when you are making the so-called leak test. The most probably difficult to pass is the test of the machine with doors, because in one of the tests of Annex CC, you have to have a leak inside the machine and then suddenly open the doors. Therefore, all the charge will go outside. So this is probably the most severe case that the ventilation has to reduce or disperse the cloud in this case. So maybe in some cases the charge limit is 500 is even too big for assuring to pass this test. There are situations where probably ventilation is even not necessary, like when you are having all the refrigeration system on the top of the system. So in case of leak, this will fall down without creating the flammable concentration. Now, this standard was approved at an IEC level, and most of the nations that don't have their own standardization system, they can use already this standard. In Europe, to become a harmonized standard has to go through the CHENELEC committee, TC61, and in fact presently is under evaluation basically by European consultants to become a European standard, that's 89, harmonized with machine directive. If you go to the website of CHENELEC, you will see that the target date for the final vote is March next year. We hope that will be faster, but it's quite difficult to predict now exact date when European version of the standard will be released. In US, there is a working group 12 under Canina. I'm also part of this group and already prepared the draft of the American version of the -89 standard, and probably will be first vote will happen still this year. American version is introducing several deviations or changes versus IEC version, because they probably will cover also many applications of remote system that the IEC version is not considered. New Zealand and Australia already released recently in July this year the Australian-New Zealand version of the standard. In Japan, the working group 3 of JARAIA, the Japanese Industry Association, is working on the Japanese version of the standard that originally was said that will be released this year, but I have some doubts because they are still working on the deviation that will be introduced for Japanese version of the standard. Now, flammable refrigerants to replace 404A, that is a major issue in plug-in applications, are those you can see here. No? So there are different mixtures or in A2L class, and we have a propane. I'm showing those refrigerants because there was a part of the work we did in with EHRI in 2000, starting in 2014, I think. So this presentation is from 2016. So there was a program under EHRI to define the low GWP alternatives for the future. So we have tested those three A2Ls candidates and compare them with propane. So basically, all of them obviously are able to replace 404A, and as you can see, most of the A2Ls are having better efficiency than original 404A, but in any condition, -10, so typical medium temp or low temp, the propane is showing substantially higher efficiency than any of HFCs or unsaturated HFC blends. 2016, we prepared a study, and it was presented in Purdue conference, showing what is the difference between A2Ls and propane in terms of thermal level. And as you can see on the left, there's a graph showing the internal temperature of the compressor compared to the, let me say, baseline of 404A, and in red, the propane. As you can see, the A2Ls are showing significantly higher temperature level. That has to be mitigated in some way. Anyway, without any mitigation, it means your envelope basically has to be reduced, to be applied in the real world. So because of this higher thermal level, we will be suggesting to reduce the envelope or adopt other means to reduce the temperature. Propane is having the same or even larger envelope than original 404A refrigerant was offering. So in summary, our conclusion in terms of comparing 290 with A2Ls is obviously higher efficiency, lower temperature, so larger envelope, higher reliability, no temperature glide is typical of those low GWP blends. We have a much lower refrigerant charge, so the less issues with liquid return in case of frost or whatever. Obviously, the price of the natural refrigerant is much lower. We have low GWP, you know, we have still difference because propane is 3 and others are around 150. And we have also a little bit lower pressures in terms of operation on given condensing evaporative temperature. Therefore, it's easier to meet in Europe the PED requirements. And here is the last slide of my presentation showing not only the Embraco readiness for below 150 GWP, where basically propane is, we are offering for all the various product sizes we have in commercial refrigeration, but also all the options we have in this transition period before the Kigali Amendment will enter full in force, where use of refrigerant with very high GWP is not possible. There is a period of time where the refrigerants below 2500 GWP can be still used. In fact, is probably today in many fields is dominant solution. Anyway, as you know, propane is already on the market since quite long time, and its use in plug-in is, let me say, obvious, at least for us. Even if obviously the option of other low GWP products is possible, and in fact Embraco, for example, in the field of YF, that is replacing 134A in specific applications, is producing compressor for YF since a long time. Okay. So thank you. Maybe I was too fast, so please make your question. I'm here to try to answer your points. Thank you very much.